Hi guys, Dr. Orlando here. I'm going to do a quick video on acids and bases. So, with acids and bases, we're talking about changes in the ratio of hydrogen ions and hydroxide ions. So at any given time in water, let's say you go to the tap and you get some water and you pour it into a beaker. If you were able to look at the water molecules that are in there, you would see that the majority of them are in the H2O form, that they are connected up by those polar covalent bonds with their negatives and their positive charges, just as we've drawn in every other viddle here. Okay, so that's what the majority you're going to find there. But then you're going to find a few little rogue guys that look like this, and they will be, this is regular, pure tap water. These will be equal to each other. Okay, so you'll have a few hydrogen ions and a few hydroxide ions. Okay, so it's like you broke a few water molecules. And they will be constantly bumping into each other and reforming into water, and then other ones will bump apart. And so you constantly have this mild, spontaneous dissociation of water. We call this the dissociation of water. All right, so as long as our OH negative hydroxide ion concentration equals the concentration of hydrogen ions, then our pH will be 7, which on a pH scale is considered neutral. Okay? All right, so what does that mean? pH scale and the number 7, what does that mean? Well, if you look at a pH scale, you'll see that it goes from 1 to 14. And pH actually means power of hydrogen. So the pH scale is really measuring the concentration of hydrogen in a solution. How much hydrogen is in there? Okay, so at a pH of 7, where it is neutral, okay, as I just said, the concentration of OH negative equals the concentration of H plus. So hydroxide ion concentration equals hydrogen ion concentration, and that's neutral, pH of 7. As we go in this direction and the numbers get lower, we are becoming acidic. So lower numbers mean acid. And in that case, the concentration of hydrogen ions, hydroxide ions, is less than the concentration of hydrogen ions. So on this side, we have a lot more H plus. More H plus means more acid. Okay, and a lower number. Over on this side, I'm going to draw it in blue, basic blue. Going to be going up the pH scale, and this, as we go up the pH scale, we are becoming basic, or there's base being added, and in that case, the concentration of hydroxide ion is going to be greater than the concentration of hydrogen ion. Okay, so in this side we have less H plus. Okay, so how much less? Well, that's where the power of hydrogen comes in. Okay, move this up. Okay, that's where the power of hydrogen comes in, because for every jump in the pH scale between the integers, that's a 10-fold increase in the number of hydrogen ions and the concentration of hydrogen ions. So if we take these little beakers here that I've drawn out, and let's say we were able to measure their pH, we would look at the pH. Let's look at this beaker right here with the pH of 7. Okay, so with pH of 7, we would say that the concentration of hydrogen ions is equal to the concentration of OH, hydroxide ions. Okay, and that they're equal, and so we have neutral pH. If we jump to a 6, that's a 10-fold increase. Again, it's times 10 for every jump, 10-fold increase in hydrogen ions. So now we are at 10 times the concentration of hydrogen ions. Okay, so we go from there to there. And then if we go from their pH of 7 to a pH of 5, it's another 10 times, so it's 10 times 10. It's 100-fold or 100 times the concentration of hydrogen ions. Okay, so you have a big jump just going from a pH of 7 to a pH of 5. You've increased the hydrogen ions by 100 times. Pretty significant. And if you go down to 4, it'd be 100 times 10, which is 1,000. And you keep going on the powers of 10. Okay, so big jumps in the concentration of hydrogen ions between the numbers, between the whole numbers. Okay, so let's have a look at there. Where do all those hydrogen ions come from? That can change the pH. Well, a lot of places in the body hydrogen ions can come from, but this is just an example. You can take this beaker here and we can say we're just going to put water in it, so it's going to be mostly water. It's going to be a little bit of hydrogen ions, and I'm going to make this little bigger here so I can draw better. It's going to be a little bit of, get my blue, a little bit of hydrogen ions and a little bit of hydroxide ions. So our pH equals 7. This is water. Well, what if we took that beaker and we added some HCl, hydrochloric acid? We're going to drop that in there. Add acid to water, right? Do what you ought to, add acid to water. So we're going to drop it in there, and you get, you know that this is water in here. Got our blue H2O in there, and that water is a polar covalently bonded molecule. It has a negative side and a positive side. Hydrochloric acid is ionically bonded. And as we've learned in previous lectures, ionically bonded molecules will dissociate in water. So we're going to put that in there, and it's going to dissociate, which means it's going to break apart. H plus Cl, H plus Cl. Okay, just to be thorough, that water also has some hydrogen and OH, but it's equal quantities because it was pH of 7 when we started. Okay, so we added hydrochloric acid crystals to it, and boom, it's dissociated. Now we got a bunch of free hydrogen ions. And what are they going to do to the pH? They are going to change the pH, and they're going to make it less than 7. How much? Well, it depends on how much hydrochloric acid you put in. Put in just a little bit, it's not going to be a big change. If you put a whole bunch in there, it's going to be a big change. Okay? All right. So that's acid. I just mentioned there too, like I said, it depends on how much you put in. Hydrochloric acid is responsible for helping us digest food. So the pH of the stomach acid is actually less than 2. So that's a pretty significant amount of hydrogen ions floating around in your stomach right now. Okay, so that's how we make an acid solution. or make a solution acidic. Okay, how do we make it basic? Let's do it like this. Oh. Yeah, I'll make the solution acidic and make it basic. That's a better way to look at that. Okay, so make it basic. How are we going to do that? Well, we're going to have a solution of water, which is going to be mostly H2O, a little bit of hydrogen ions, a little bit of hydroxide. pH is going to equal 7, and it is water. Okay, over here, make this bigger. We're going to add, let's make it green. No, let's go with blue. I'm going to keep blue here because it's a base. NaOH, which is sodium hydroxide. Again, it is ionically bonded. Okay. In there you've got a bunch of water, got some hydrogen ions and some OH. But when you put the sodium hydroxide into there, you're going to get some sodium ions and you're going to get a bunch of OH ions. So we didn't add any hydrogen ions into this, but what we did do was change the ratio. We did change the ratio of hydrogen ions to hydroxide ions. So now we have a lot more. So if we were to look at it, we would say that the concentration of OH, hydroxide ions, is greater than the concentration of hydrogen ions, and therefore this is a base. And again, the pH would be greater than 7. How much? How far? Again, it depends on the concentration. You can have a very strong solution of sodium hydroxide that would be up at 14. Very, very strong base. Okay, there's acids and bases. If you have any questions, please feel free to email me or call me. Have a good day.